Exercise 2.25. The missile's engine exerts a 260 kilonewtons force F. A. Express F in terms of components using the coordinate system shown. B. The mass of the missile is 8,800 kilograms. Determine the magnitude of the sum of the forces exerted by the engine and the missile's weight. Well, as always, first step, writing down the information that the problem is given to us. So I have that the missile engine exerts a 260 kilonewton force. That means that I'm going to have a force vector which magnitude is going to be equal to 260 kilonewtons. A. Express F in terms of components using the coordinate system shown. Alright, so they're asking for me to find the vector F in terms of the components. So Fx along the I direction plus or less, we are going to see that later, Fy along the J direction, because we are talking about just a plane that is xy, right? That is why we only have two components. So as you can see right here, I have towards this direction positive numbers for y, towards this direction positive numbers for x. That means that towards this direction I'll have negative, and towards this direction I'll have as well negative. As you can see, this vector F is compound, or is the solution of a summatory of two vectors because it has an angle. The first one is going to be this one. As you can see, is pointing towards the same direction of x, so I can say that the first component, or the component along the I direction, which is related to the x axis, is going to be positive as well. And the same thing goes for the y direction. It is going to be positive because of the same reason. Now, they have given to me a triangle, specifically a triangle rectangle triangle, because right here I have a 90 degrees angle. So I'm going to do this triangle once again. This is 3, this is 4, and I am able to find the magnitude of the hypotenuse. So we're going to look for it. The hypotenuse is going to be equal to the square root of 4 squared plus 3 squared. This is going to be equal to square root of 4 squared plus 3 squared. 5, right? Right here I have the 5. Now, we're going to use a concept called the unit vector. Unit vector. I've explained this within my previous videos, but we're going to do it once again. For when I talk about a vector, there are two things that occur the most, and those things are the magnitude and the direction. But the unit vector, as the name suggests, is a vector whose magnitude, is equal to 1. It is always 1. A unit vector is always represented by a little hat above the letter of the vector, right? As you can see right there. Now, I don't really care about the magnitude because I already know that is equal to 1. I just care about the direction. A unit vector is used for me to transform all kinds of vectors pointing towards other directions, because I can play only with that, right? Now, there are two ways in which I can find a unit vector. Every vector has a unit vector. For example, if I have a vector like this, which has a magnitude of 0, 1, 2, 3, 4, I'll have that the magnitude of this vector is equal to 4, right? The magnitude, we're going to call it vector B, for example. The magnitude of this vector is going to be equal to 4. Now, the unit vector is going to be this one, right? So the unit vector of B is going to be equal to 1, and it is going to be this one. Now, as you can see, it is pointing towards the same direction as the vector, right? I want to explain you this because I think that is much more easier for you to analyze it that way. Now, because of this, I can say that the vector B divided by the magnitude of the vector B is going to be equal to the unit vector B. And this is our first way for us to find the unit vector. The second way is by using their components. I'm going to do it right here. For example, if I have a two-plane axis, y and x, and right here I have a vector which is also v, for example, that vector is going to generate an angle between the vector and the x-axis that I'm going to call alpha. Then the unit vector v is going to be equal to the cosine of the angle alpha plus the sine of the angle alpha. Remember, I've used positive numbers for the cosine and sine because the magnitudes are pointing towards the same directions of the axis as we analyze here. Now, remember, the cosine is related to the x-axis. That means that this is pointing towards the I direction, and this plus the sine of j direction, the y-axis. So right here we have our two ways for us to find this, the unit vector. Now let's see in which case work for us to solve this exercise. So I already have the magnitude of the triangle that they gave to me, right? Now I am perfectly capable of finding the unit vector of this vector, right? Why is that? Because this vector, for example, I'm going to call it, I don't know, F2. F2 vector is going to have two different components, which are going to be 4 along the I direction plus 3 along the j direction, right? And I already have the magnitude of the vector F2, which is equal to 5. Now, using this equation, I am perfectly capable of finding the unit vector F2. So F2 unit vector is going to be equal to 4 divided by 5 along the I direction plus 3 divided by, once again, by 5 along the j direction. Remember, the magnitude, the vector divided by the magnitude. The vector divided by the magnitude. Now, I'm gonna use this. I don't want to use decimal numbers because I think that I'm going to lose some decimal numbers right there, so I don't want to. Now, there is something else that you should know, and it is that for when I have a vector, for example, the vector k, and the vector, for example, the vector j, if both of them are parallel between each other, that means that the unit vector of k is going to be equal to the unit vector of j. Alright, this is a property. Now, because of this, as you can see right here, F2 is parallel to F. F is parallel to F2. Now, this is also the unit vector of F. right? Now we have the unit vector of F. We have the magnitude of F, because the magnitude of F is equal to 260 kilonewtons. That means that I'm perfectly capable of finding the components of F using, once again, this equation. So F vector is going to be equal to F vector is going to be equal to the F unit vector multiplied by the magnitude of F, the vector. Now F vector is going to be equal to 260 multiplied by 4 divided by 5 along the I direction, plus 3 divided by 5 along the J direction, and this is in kilonewtons, sorry, kilonewtons, right? So 260 multiplied by 4 divided by 5, 208 on the I direction, and I just have to change this by a 3, plus 156 the J direction. This is in kilonewtons, and right here we have our first answer. Then the second answer. The mass of the missile is 8,800 kilograms. Determine the magnitude of the sum of the forces exerted by the engine and the missile's weight. Alright, so right here I have something like this. F pointing towards this direction. We already know which direction is pointing because of the components. F, but they are telling me that I have to take into account the weight. Remember, for when you are using the weight, you have to be pointing towards the center of the earth, in this case pointing down. The magnitude of F is equal to 260 kilonewtons. And right here I have the mass of the missile. So the mass is equal to 8,800 kilograms. The mass is not a force, right? Because a force is always represented in newtons, or in pounds, or in force pounds, when we are talking about the use customary base units. So all we have to do is to transform this mass into a force. Remember, a force is equal to a mass multiplied by an acceleration because of Newton's second law. Which acceleration? Well, since we are in the earth, right? Then we are going to use the gravity acceleration. So the force that is exerted by the weight on the missiles is going to be equal to 8,800. I always like get wrong with that. 8,800 multiplied by 9.81. At the end, this is going to be equal to 86,328 newtons. You know why? Because right here I have kilograms multiplied by meters per square seconds, and this is equal to having a newton, right? But I wanted to use kilonewtons. Why is that? Because I have this already in kilonewtons. So all I have to do is to either write down the equivalence, which could be 86,328 times 10 to the sorry, this is not right. I could either transform this by writing down the equivalence. I was going to commit a mistake, sorry. By multiplicating this, right here I have newtons. Right here I want to change those into kilonewtons. So I already know that 1 kilonewton is equal to 1 times 10 to the third power newtons, right? So no, this is not. I want to eliminate the newtons. Sorry about that. I just got confused. It is part of the way I always say. That is why I do not like eliminate this part of the video, because it is pretty normal. So right here I have newtons, right? Newtons is right here, so I should get rid of them. So I'm gonna write down newtons right here. I'm going to write down kilonewtons right there. I already know that 1 kilonewton is equal to 1 times 10 to the minus 3 power. This is one way in which we can do that. But I already know that it is easier for us to move this comma 3 spaces. I already know this, right? So 1, 2, and 3. So this is going to be equal to 86.328 kilonewtons. And now we have our weight, kilonewtons. So W has magnitude of 86.328 kilonewtons. Right? And they're asking me to find the summatory of the forces. Remember, for when you are doing a graphically speaking, summatory of vectors, all you have to do is to find this vector. Head with tail for the vectors that are adding it between each other, and for the solution, tail with tail, head with head. Now, at the end, I don't want to use trigonometrical identities for me to find this, because I already have the components. So the resultant vector R is going to be equal to 208 on the I direction plus 156 on the J direction plus 86.328 along the J direction. Everything is in kilonewtons, so I can add them. Now the resultant vector is going to be equal to 208, since I don't have any other component along that direction, and 156, sorry, this is not plus, this is minus. Should be subtracting. Why is that? Because W is pointing towards the opposite direction of Y, so it has to be negative. Remember, positive, negative, as you can see right here. Now 156 minus 86.328 right, plus 69.67 on the J direction. Right here, half first part of the answer 2. And so B, first part, and the second part, the missile's weight. We already did that. Right here we have our second answer for the B problem. So at the end we just have to always we just have to find the magnitude by using the square root. So 208 plus 69.672 square, and this is equal to square plus 69.672 square, 219.3585 kilonewtons, right? Because the exercise is asking for the magnitude of the sum of the forces. And right there we have it. And that would be all, guys.